Yes. This is a general introduction definition for interpolation. Interpolation proceeds a function that matches the given data exactly. The function then can be utilized to approximate a data value at intermediate points. So it's a technique to find out an intermediate value. Suppose that you are having data for more variables, but you have missed one point in the middle point. So you can calculate and you can approximate some value for that space. It's useless of ignoring that variable or that missing procedure. So you can use an alternative procedure to match a value or approximate a value for that missing space. This is spread. Then today I'm going to use some spreadsheets, and I'm giving you a hypothetical data set, and I have already shared some data tables with you to interpret some interpolation techniques regarding the demography. This spreadsheet interpolates population data by single years using 4 mathematical equations divided by Sprague, Karupkin, and Beers. So then in demography, most probably we are using these techniques to convert some group data into spread format. So most probably we are having 5-year or 10-year gathered data set. So we can interpolate, we can illustrate those data into single year age distribution by using these techniques. It gives also a graphical presentation of fitted curves. What you may require to do this just to type your data in table 1. So I will introduce you what are the tables later. Then you will realize your data may be for a total population by sex, but it must be in 5-year interval. You need only to enter the first 5-year age groups. Okay. Okay, now you have a mathematical formula. So this is a general mathematical way of doing interpolation. So I will use my laser point. Yeah. Then you can see the green, white, T. Suppose you have values for these all black letters. I mean for x1, x2, x3, and y1, y3. You have observations for these things. But you missed or you don't have value for y2. Then what are the things you can do? You can ignore that one. In one way, you can ignore yt. And we need those information to, suppose you are going to calculate the correlation in between x and y1. So in this slide, I am discussing about the general thing, not about the focus for the demography, but that knowledge you can apply for the demography also. But generally, when you use other things like in mathematical things, that is the way we can deal with these two. You can find the correlation, at least you can find the correlation. Other way, you can estimate some regressions, simple linear regressions by using these informations. But with the missing value in y2, it is somewhat useless, because without having this observation in this sense of I will highlight that. Suppose you don't have this one, then it is useless of doing an estimation by using this x2, x3, y3, and x1, y1. So it is important to have this y2. So what we can do, we can do an approximation for this step. So you can use these 3 equations to do that job. Then I will share an example with you. Okay, I will write down in here. Suppose about these values. Then suppose you are having 21, 24, and 27 as x1, x2, and x3. And also you have 40 for y1 and 50 for y3. Now you need to find out value for here. So you can apply these three equations. But I have given you three equations. The value placed in spaces are somewhat different. So in this equation, this is yeah, first this equation, this is x2. So this value is x2, this is x1, this value is x1 and x3. Here the x values have given as 1, 2, 3. But in this equation, that procedure is somewhat different. Here they have mentioned x0, x and x1. That's the way they have mentioned their value. So for the y, this is y0, y and y1. So the placement of numbers are somewhat different in between these equations. So the third one, what they have used y1, y2. That procedure they have used for the x1 in the middle it is x, the later part it is x2. Okay, now I have given you a hypothetical data set. This is the hypothetical data set. Now you can calculate values for this missing space. Use these three steps and use these three techniques and find out what is the value should come into here and compare these three methods. The answer should be 45. That's the answer for this missing space. It should be 45. Then 45 should come in these three equations, so you can try it. Okay, then the Newton's formula. We use Newton's formula to convert 10-year age group into 5-year age group. So this equation is for calculating the first half. Then don't forget about that. We use that equations to calculate the first half. Then during in the 10-year age group, we can use this Newton formula to obtain the first half. Then this is the equation. This is the Newton's formula. Then you are having a hypothetical data set here. Then that's for 10 years from 15 to 25, 25 to 34, 35 to 44. Then these are 10-year age groups. So this is the population. Then you have values for these three. Then by using these three, what you can find the middle space, age group, first half. Using this equation, you can find the middle age, first half. So this is the way of values are coming. Then you can calculate this one, population for 25 to 29. Okay, then I have given the way of these notations are coming. Now you can subtract these things in this equation, I mean these values for the equation, and calculate the first half, if not the population for 25 to 29. Okay, go forward. Okay, now I'm going to include the values into this equation. So I don't need to include because I have already given that value. So F1 is what? 3,233. Then Fn minus 1 is 4,040. Fn1 is 2,655. Now you can simplify this equation. Now I have subtract values for there. So now you can, okay, as the first step, you can simplify this bracket. That is 4,040 minus 2,651. The answer is 1,389. Then you need to divide it by 8. So that's the thing here. If you have divided by 8, what is the answer? You will have 100 73.625. Then you need to add F1, Fn to that value. You need to add 3,233 to 173.625. Then answer is, I did not add that summation into here. Anyway, the answer is 300. 3,000, sorry, no, 3,406.625. Again, you should divide that by 2. That's the thing in here. If you divide that value by 2, you will have the answer as 1,700 1,703 point 3125. The answer is 1703.3125. So I received correct answers from some student. So this is the way of simplifying this equation. So you can try it again leisurely by using some different values into this one. So this is about what? That is the value for first half of your middle age group. So your middle age group in here is why I am using this middle age group. So to find out the first half of this one, you need the upper and lower both cases. So to find out the first half of age group of 15 to 24, you should have the 10-year value of age 5 to 14 age group. Likewise, you need the previous case value also. That's why I use. Then this is the value for this range 25 to 29. That is the first half of this 10-year group. Okay, I think you have understood that. If you have a question, you can ask. Okay, now you have a data set. What it says, population data by 5-year age group. Then now forget about the Newton's formula. I introduced that one to make your 10-year age groups into 5. Here onward, I'm only using 5-year age group. So if you have any cases with 10-year age group, now you know how to turn those 10-year age groups into 5-year age groups. After finding the first half, you can subtract that part from the total, I mean the 10-year age group, then you will have the second 5-year, second half or a second 5 years age group value also. So I think now you know about that part. Now I am moving for the single year age distribution constructing way. So here I have 5-year age groups. So from 0 to 24. As an example, I use these things in here. You have male population, female population, and the total. So let's see how to use that. Then, as I told you at the very early, here I used 4 methods: Karukin's method, Sprague, and Beer's ordinary method, and Beer's modified method. Even though I introduced these 4, I will discuss this one, Sprague multiplier, in detail in your course. But I have given all information for these 2 also. By using the knowledge you are obtaining along with the Sprague multiplier, you can test other things also. But I am not going to waste our time to conduct these all things. I will introduce you this Sprague. By using the knowledge you are obtained from this, along with this Sprague, you can utilize that knowledge for other things also. Then you can check your answers with this one also, because then this is for the male population, this is for the female population, this is for the total. Okay, then I'm going to move for the intermediate calculations using these techniques. Okay, this is the Sprague table. I have already uploaded the handout to LMS. Now you need to refer that table to make these calculations. Okay, then some things you need to remember before moving for the calculations. Yes, to find out, this method is applied as, let us take 5-year groups of cohorts N0 that we wish to break down into 5 cohort by age. By using the values along with 5 things, we can find out the value for this one. Then, okay, let's see this one. To estimate, for example, the cohort at 27 year, which correspond to N3 in the 5-year age group 24 to 29 were given. Now forget about the 10-year cases. As I told you earlier, we are using only 5-year cases to this one. So if you have your data set in 10 years, first you need to convert those into 5-year age groups. Then you can apply these techniques. And okay, then here you are having age groups. Then this is from 15 to 19, this is 20 to 24, 25 to 29, 30 to 34, 35 to 39. Then you can, even though you utilize these all information by using this Sprague multiplier, you can have single layer age distribution only for the N0 age group. That's the thing this slide also have said. Even though you used these 5 age groups for your calculations, you will have single layer age distributions only for the N0 age. So that's why you are having 5 columns here. We are using 5 age groups for these 5 years, but you will have single year age distributions only for the ages in N0. So the order, if you have mentioned those things orderly here, N0 is coming for this one. Then as it mentioned in here, that is about 25 to 29. So you will have single age distributions for 24 to 25. Then forget about this one. It is something another thing according to the previous data set that is telling about this one. But this example is somewhat step change thing. Then that was in here 25 to 29. So after doing this all simplification, you will have 25, 26, 27, 28 and 29 here. So after adding those 5 values, after adding those 5 columns, finally you will have single year age distributions value for 25, 26, 27, 28 and 29. That's the thing in here. I think still you are not having a good understand about that one. Anyway, you will solve that problem when I'm introducing an example. Okay, then let's see this one. We need to multiply our table values by using these age values. That's the thing we are doing only here. But it is somewhat confusing. Sometimes it may be confusing, but I think you will catch it well. Which gives the cohort of individual who are 27 years old. Okay, forget about these things. Okay, now I'm going to do the calculation. So I will introduce only this one, a Sprague multiplier. Then you can practice these things also. Okay, then I have given you 5-year age distribution. This is about Sri Lanka. So here also you can see total male and female population. So I will introduce you the calculations for the total population. Then you can practice male and female leisurely as a homework. Okay. Now you need to take these values into your note, or you can use your handout also, but we need to have this Sprague multiplier also our hand. So please obtain these values.
Madam, can you explain it in Sinhala?
Yes, what we have done, we have used the values of our first 5 age groups in the top of our table. Then this is for the age for age 0 to 4, this is for 5 to 9, this summation of 10 to 14, this is 15 to 19, and this is 20 to 24. Then what you are going to do now, we are going to find the single year age distribution for our first 2 groups. To find the single year age distribution for first 2 groups in our whole data set, we can use this part of our Sprague multiplier table. Then we use these 2 for the last part. So in our data set, the last 2 5 age groups are 70 to 74 and 75 to 79. So 18 onward, they have added all things together. So it's not a 5-year age group. So we can use this part to find the single age distribution for 70 to 79 age. in our data set. So that is dependent on the data set. Then as we discussed at the very early, then this data set has only a data from 0 to 25. So directly we can apply it into in this way. So this is about a continuous data set only from 0 to 24. But when we have data set more than this range, we have to consider about something differently. So we use this part for the first two groups and this part for the last two groups. So when you're having last two groups values into here, you need to put the last 5-year age group into here, the previous one to last into here, and accordingly other previous things in for these three things. Otherwise, for the middle case, we use this part, the G3, to calculate other things. Okay, then when you use 0 to 9, I think you have already completed that part. Then to 10 to 14, you can use this data set in this way, but not for other two things. Only for age up to 14, you can use this table. Okay, the student who completed this part, calculate the values for next one. Then when you are starting to calculate ages for 15 to 19, what you should do, you should add this summation into G3 group. Then you need to arrange other things accordingly, and you can simplify this part again, and you can have values for 15 to 19. So before moving to that part, now you can complete this one, 10 to 40. I will insert value of spread multiplier here. I do not include the last column because all values are 0. So then I'm going to include multiplied values here. So if I put it in the way you have, this is G1, this is G2, G3, G4, G5. Then these are the single age distribution: 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12, 13, 14. Okay, what I need to do, I need to multiply this value by this value. And I need to multiply this value again by this value. Now you can compare your values in these steps with my values. Okay, then I'm going to take the summation of these. So these are the answers you should have for 0 to 4 group. Now you can check what are the misleading things you have, and you can make clarifications. So when you are having some minus values in here, because there are some minus value in the table, so those should be reduced. Okay, these are the single age distributions for age 0 to 4. If I compare the answers you sent me, Yeah, one of you have completed that well. Then I don't know whether he or she also have some misfitting in the 1 point. Then after we add in these all together, we should have the previous value. Let's see. Yeah, that should be equal to this one. So I think sometimes there may be a problem in my case. Anyway, the thing is we need to compare our all answers, then we can find. I think there may be a wrong point in here. Let's see. Yeah, there may be a wrong point in here because other answers are same, my answers and her answers, but 1 point is different. I think that may be this one. The wrong point is in here. I have multiplied this one. It should be this one and one. Okay, now I think it's correct because now we are having same value at the summation of this one and the total of this cell for the age group 0 to 4. Then you can cross check your answers whether correct or not by using this method. You can add up these all together for the 5-year age group, single age distribution. You can add up those all together and compare with the previous value. Exactly, I am having the previous value, so I have made a mistake in this step. So I think most of you have similar answers. Okay, then you can complete the rest of the thing and bring your answers for the next day lecture. Okay.